So I received a really good question about how to find fractions on a number line. So I thought I would start out with the question, how many numbers are there between 0 and 1? So if we were to draw a number line and we call 0 like the middle point of our number line, and then let's say over here is 1, well, all of the numbers that exist between 0 and 1 are going to be what we call proper fractions. So proper fractions have a numerator, a, that is smaller than the denominator, b. So a is less than b. And so we can start with this number line and we can actually cut it in half. So that's really easy to do. So here would be my halfway point. And then from here, we can keep cutting this up. So if I cut it into 4 equal pieces, here I have 1/4. This would be 2/4 and 3/4. And then of course you could have 4/4. So we have 1, 2, 3, 4 pieces. And if I count from 0, I'm going to have 1, 2, 3, 4 dashes past 0 to get to 1. So can we keep cutting this up? Well, sure. If I cut again each slice in half, now I have 1, 2, 3, 4, 5, 6, 7, 8 equal slices. So that makes this 1/8. Here's 2/8. Here's 3/8. Here's 4/8. Here's 5/8. Here's 6/8. Here's 7/8. And here's 8/8. 8/8 being 1 whole. I actually didn't mark 2 halves. I could have done that, and actually, in a way, almost need more space, right? Because it gets really crowded. So the point here is we can always keep dividing this up. We can divide it further and further, and that actually means there are an infinite number of fractions between 0 and 1 in an infinite amount. But you can see here, if I continue to cut this in half, each slice in half, now I'm going to have twice as many sections. And so essentially half of an 1/8 is a 1/16. So here's a 1/16. Here's 2/16, and you'll notice that 2/16 is equivalent to 1/8. So these are all our equivalent fractions. Here we have 3/16, which can't reduce. It doesn't have an equivalent fraction here. I mean, it can have equivalent fractions, but it doesn't on this chart. We have 4/16 is equivalent to 1/4. So 4/16 is equal to 1/4, and that's because 4 divides evenly into each. Here we have 5/16, 6/16, 7/16. Here's 8/16. Half of 16 is 8, so that's why that's equivalent to 1/4, or sorry, 1/2. 9/16, 10/16, equivalent to 5/8. That's what we call simplified. What was I on? 10, 11/16, 12/16, 13/16, 14/16. It's really crowded, and 15/16. And then 1 whole is equal to 16/16. So it depends on how many sections you have. And this is actually the exact same thing that is going on a ruler. So if we look at the end of a ruler, and notice that's not true on the metric side. So if we're still using the customary side, here we have the long line represents 11 at the end of the ruler, and then this long line represents 12. Well, in between, and that's why we're staggering the sizes, this is going to be 11.5, right? Oops, let me get a better color that's going to show up. So that's going to be 11.5, and we really just mark the half halfway point, but because we're past 11, if I measured to here, something measured, let's say I measured a board to here, it would mean it's 11, a mixed number, 11 and a half, so more than 1. That mixed number could be made into an improper fraction as well, but you see the next dash down from that, it's a little bit shorter than the 1/2. This is a quarter, and here would be 3/4. From here, you have the smaller dash. Now we're cutting them into eighths. And this, by the way, all the way over is 12. So here's 1/8. We don't mark 2/8 because that's equivalent to 1/4, and we call 1/4 completely simplified. So just the fractions that are new, just the new lines. So 4/8 is going to be 1/2, but we'll skip that. We have 5/8 here, and 6/8 is there. Sorry, I miscounted. So that's going to be 7/8. And then if you got all the way to the end of the line, that'd be 8/8. If we take these smaller marks now on the ruler, these are going to be our 16ths. And like I said before, we're not going to mark every line, but we do have 16 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, all the way to the 1 hole. So we have 1/16 being the smallest, 2/16 is equivalent to 1/8, so we skip that. 3/16, 4/16, 5/16, 6/16, 7/16, 8/16 would be 1/2, 9/16, 10/16, what was that? 11/16, 12, 13/16, 14, and then 15/16. And like I said, 16/16 would give us the whole. So that's how we use a ruler to measure. Of course, you could go down further. There's going to be, like I said, an infinite number of fractions, but they're going to get smaller and smaller and smaller. So they're less useful when it comes to measurement. But it doesn't matter. Like if you have a number line and here's 0 and here's 1, you don't necessarily have to break it up this way, right? If I wanted to break it into thirds, and we didn't see thirds coming up on the number line, but if I break it into 3 equal sections, I could call this 1/3, 2/3. This would be 3/3 is 1 whole. 4/3 is improper fraction. That would be 1 and 1/3. So if I say, it really depends on how we break up the number line. If I say that this is point A and this is point B, A would be equivalent to 2/3. And then I have to look and see, okay, I'm still using that same increment to cut things up. So B would be that mixed number, 1 and 1/3, or an improper 4/3. Let's look at another example. So let's say I were to take my number line. Here's 0. Here's, let's call this 1. Let's call this 2. And if I want to break it up another way, typically we use that ruler method, but we just have to really count how many sections I have. So here I have 1, 2, 3, 4, 5 sections. That makes this 1/5, 2/5, 3/5, 4/5, until you get to the 1 whole, 5/5. So if we continue that same markings, and imagine these are all the same size, although actually I realize that would be 3 because we have 4 cuts makes 5 sections. So imagine that one is 3. So then if I were to say, well, this is point C, we would see that since I'm past the 2 and I'm 2 marks past, that's going to be, whoops, go away, screen. There we go. Now I'm on the wrong page. So where was I? Yes. Right here. So this point C is going to be 2 and 2/5 based on where it's marked, this point, because I'm counting by fifths, because my number line is to divide it into 5 equal sections, which we don't typically see on a ruler. On a ruler, we're always going to use this situation with the halves, you know, halving those sections. So you're always going to see in the customary system of measurement in terms of inches, we always divide it up this way. So you'll see 8/16, 4ths, halves, but you're not going to use thirds on the ruler. I mean, it's just not marked for that. You could have a ruler with thirds, but we typically just don't. Whereas with the metric system, we are using a base 10 system. So, you know, you'll have 10 millimeters is equal to 1 centimeter. And that's where you're seeing all these little dashes by 10. So that's going to be 5. And then each one going to 1. All right, well, hopefully this was helpful looking at numbers on a number line. Or I should say fractions on a number line.